Welcome to the deep dive. Our mission is simple. We grab a bunch of sources, we dig in deep, find the absolute best insights, and, well, we serve them up to you. Think of it as your shortcut to being really well informed, hopefully with some surprising facts and maybe a little bit of fun too. Today, we're diving headfirst into what feels like a really crucial fork in the road for, the planet's future. We're looking at two major, very different strategies for dealing with climate change and meeting our energy needs over the next, say, 25 years.
That's right. It's like path one is this vision of a total, pretty rapid shift, everything moving to renewable energy sources. And then path two. Well, that's a future that tries to keep a lot of our current system going, mostly fossil fuels, but leans really hard on carbon capture tech to clean up the mess afterwards.
Yeah, and guiding us through this is this really compelling study. And frankly, it's quite assertive. It was published in Environmental Science and Technology. It looks at these two paths almost like extreme ends of the spectrum. And it reaches a conclusion that might actually surprise you.
Yeah, what's really interesting, I think, is how rigorously the researchers set this comparison up. It's quite something. They didn't just look at, one country or one little sector. They modeled these two really distinct approaches across 149 countries. And they looked at the potential costs, the benefits, the kind of wider implications of each path over the next couple of decades. It's pretty comprehensive.
Okay, let's unpack this then. So they basically built two hypothetical worlds, right, to see how they measure up against each other. World number one, the big shift.
Precisely, yeah.
Yeah.
So in this first scenario, they modeled what happens if these 149 countries move completely away from fossil fuels and biomass too, across all the energy sectors. So that's your electricity, heating, cooling, transport, industry, the whole lot. By 2050, and all that energy would come from 100% renewables, wind, solar, geothermal, hydro. Oh, and this world also included some pretty significant energy efficiency improvements. And using things like green hydrogen strategically for those sort of hard-to-electrify jobs.
Right. So a world running entirely on clean energy, but also getting much, much smarter about how we use energy to begin with. That sounds, well, pretty ambitious.
It is, definitely. Now, for the comparison, the second scenario is designed to be, equally ambitious, but ambitious in a totally different way. So here, countries pretty much keep their existing energy mix, still heavily reliant on fossil fuels, nuclear, biomass. But they also roll out carbon capture technologies on a just massive scale. We're talking capturing CO2 from industrial smokestacks and using direct air capture tech everywhere, just sucking CO2 right out of the air. And critically, this is important, they applied the exact same level of energy efficiency improvements in this carbon capture scenario as they did in the renewable one.
Got it. Okay, that's really key, isn't it? So it's not renewables versus doing nothing. It's renewables plus efficiency versus fossil fuels with this massive cleanup operation, plus the same efficiency. They called them unrealistically extreme cases, I think. But doing that really helps sort of isolate the core differences, right? And the potential of each approach.
Exactly. Clarifies the comparison.
Yeah.
And the findings. Well, the study concluded that the 100% renewable energy transition isn't just, a little bit better. It would actually be significantly more beneficial and more cost-effective than trying to manage emissions with carbon capture while, still burning all that stuff.
Significantly. Yeah, that feels like an understatement looking at some of these numbers. The study found that if these 149 countries went the full renewables and efficiency route, they could actually cut their total end-use energy needs. That's the energy we actually use, right? In our homes, cars, businesses. Cut it by more than 54%. Just think about that. Needing less than half the energy we currently use.
Which naturally has huge implications for costs.
Yeah.
Massive. They worked out that the annual energy cost for all these countries combined would fall by nearly 60% compared to that carbon capture scenario. But honestly, the most striking finding, for me anyway, wasn't really about the money. It was about health. Public health.
Oh, yeah. Tell me about that.
Well, the study estimated, get this, a full shift to renewables could avoid hundreds of millions of illnesses and prevent a staggering 5 million premature deaths every single year. Deaths linked to air pollution from our current energy sources, pollution from power plants, cars, trucks, even things like wood stoves.
Wow. 5 million deaths annually. Avoided. That number is just, it's huge. And it really highlights something fundamental, doesn't it? When you swap out, say, a gas power plant for wind or solar, you're not just ditching the CO2, you're also getting rid of all the other horrible stuff coming out the pipe, right? The particulate matter, the sulfur dioxide, nitrogen oxides,
Yep.
the things that directly make people sick.
Exactly.
And carbon capture, well, it might aim for the CO2, but it doesn't touch those other pollutants, the ones from the actual burning.
Precisely. It can't. And the study really hammers home the efficiency difference, too. Electrification, when it's powered by renewables, it's a fundamentally more efficient system overall. Think about electric technologies, like heat pumps for heating and cooling, or EVs. They just use less energy to do the same job compared to, say, a furnace or a gasoline engine. Plus, you cut out all the energy that's wasted just digging up, moving, and refining fossil fuels in the first place. There's a huge energy cost there, too.
Huh. So it really is like the difference between constantly mopping up a leaky pipe versus just fixing the pipe, right? One takes constant effort, money, energy, and you still might have water damage. The other just stops the problem at the source.
That's a great analogy, yes.
Yes.
One of the authors actually pointed out that, look, even if you had some kind of magical, 100% efficient way to suck CO2 out of the air, it doesn't change the basic inefficiency and the other pollution caused by burning fuel. It is inherently more efficient and cleaner, obviously, to just get energy from sources that don't involve setting things on fire.
Which leads the researchers to a really strong conclusion. I mean, quite an unambiguous one, isn't it?
They really don't mince words, no.
Yeah.
The study flat out states that policies promoting both renewables and carbon capture, well, they do not distinguish between good and poor solutions. That's a quote. And they argue pretty explicitly that any policy promoting carbon capture or direct air capture as a solution for our future energy needs should be abandoned.
Wow. Abandoned. That's a powerful word in a scientific paper, especially when you hear carbon capture talked about so often as, maybe a complementary tool alongside renewables. And the core reason, like you said, it just comes back to efficiency and pollution, all the pollution, not just CO2.
It simplifies the problem, really.
Yeah.
Their analysis suggests the only way to truly get rid of all the air pollutants and the climate-warming gases from energy is to eliminate the source, which is combustion itself, burning stuff.
And then there's that crucial idea of opportunity cost, too. The study brings that up, right? That if you're pouring money or even using clean energy itself to run these carbon capture systems, you're essentially taking those resources away from building more wind turbines or installing more solar panels or, developing other truly renewable things that could actually replace the fossil fuels directly.
Yeah, think about it for a second. A direct air capture plant needs a lot of energy to run, doesn't it?
Yeah.
Now, if that energy comes from a clean source, say solar, well, that clean solar energy could have been used to power homes or charge an EV or replace electricity from a coal plant on the grid.
Right.
But if you use it for carbon capture instead, you're basically creating more demand for clean energy without actually reducing our initial need to burn something else. It's kind of adding complexity on top instead of replacing the core issue.
Right. Okay, so bringing it all together then. This deep dive into this specific study, it paints a really powerful picture. An argument that a rapid, full shift to 100% renewables and efficiency isn't just one option on the table, but based on their modeling, it seems significantly more beneficial and, crucially, more cost-effective than betting the farm on carbon capture while keeping fossil fuels in the mix.
Yeah, the analysis shows it's cheaper, it uses drastically less energy overall, provides these just immense public health benefits by stopping pollution right at the source. And their numbers indicate it has a much, much lower total social cost when you factor everything in.
And the study makes that pretty stark case that carbon capture isn't just maybe less effective. It could actually be an opportunity cost, actively drawing resources and clean power away from the solutions that do get rid of combustion entirely.
Exactly. We connect this to the bigger picture. What the study essentially presents is a very clear, data-driven argument, an argument for where we should be directing investment and policy, which is, according to them, towards eliminating combustion through renewables and efficiency. That's the primary path forward, rather than, relying heavily on these post-combustion cleanup technologies.
Well, this dive into the specifics of this research certainly gives us, and you listening, a really clear sense of why these choices we're making right now about energy investment. They aren't just abstract policy debates, are they? They matter profoundly for our health, for our wallets, and, well, obviously for the climate.
Indeed. It's definitely a strong perspective, and it's backed up by some pretty detailed comparative work here.
Well, thank you for joining us for this deep dive.
Always a pleasure to unpack the research.
So we'll leave you with this thought. It comes directly from the study, something they frame as kind of a fundamental truth their research really underscored, they say. The only way to eliminate all air pollutant and climate warming gases and particles from our energy systems is to eliminate combustion itself. So, what does that fundamental idea really mean? How does it change how we think about any energy source that involves burning something, whether that's coal or gas or wood or maybe even biofuels? Something to consider.